Hello everyone, welcome back to STR8CHEM. Now we're going to learn how to write isotopic notation. But before we're going to do that, there are a few definitions that we need to know. The first one, we need to know that matter consists of atoms. But the question is, what is matter? So the general definition for matter is consists of, I'm going to rub that off first. Okay, so that is the definition of matter. Matter is anything that takes up or occupies space and they have mass. So if you occupy some space, if you have mass, and therefore you matter. Okay? So what is an atom then? Okay, so that is the question. What is an atom? So if I'm gonna reveal that to you like this. So basically, atom is from this definition, atom is the basic unit of matter that consists of a central nucleus, and that nucleus is surrounded by a cloud of negatively charged electrons. So, atoms, if you go further into the definitions and the knowledge of atoms, it has, for your level, 3 subatomic particles. Of course, we have a lot more subatomic particles, but for matriculation level, we're going to focus on 3 subatomic particles. The word subatomic particles over here refers to the thing, the particle that is inside the atom. So you can imagine that we are talking about something that is super, super tiny. Okay, so the first super tiny stuff that we're going to be talking about is electron. Okay, atom, they have electrons. And that electrons will always going to be negatively charged. And they will be surrounding the nucleus. And inside the nucleus, you have protons. And this one is, I'm going to write that properly for you, protons. And this is positively charged. And of course, in the nucleus, you also have neutrons. Okay? So for these two over here, you will find that in the nucleus. Okay, so I'm going to show you the diagram now, just like this. Okay, so this is a very good representation of what atoms should be looking like. Okay, so you have your electrons surrounding your nucleus, and then inside your nucleus you have your neutrons, the one in yellow, and you have your protons, the one in red. Okay, so neutrons and protons will be the building block, if I must say, for the nucleus, and then they will be surrounded by electrons. The most important thing over here that you need to know is the mass number. The mass of the atom is determined by the number of neutrons and the number of protons. Okay, so when you add those two numbers together, you will have the mass number for a specific atom. Now, let's move on to the next one. Okay, so how do we write isotopic notation? The one that you're looking at now, this is just the general way of writing it, okay? So you're going to have the symbol of the atom written right here, and then on top, you're going to have the mass number. Remember, mass number just now refers to proton plus neutron, or sometimes mass number can also be called as the nucleon number. And then at the bottom over here, you're going to have the proton number or the atomic number, Z, okay? A is the symbol for mass number. Z refers to the proton number. Now, so if you look at this explanation, A is the total number of protons and neutrons in the atomic nucleus, just like what I have shown to you just now in the diagram right here. You have your proton, neutrons inside your nucleus. You add those things together, you will have your mass number. Okay, so we go back to here. Z is the number. Okay, Z is the number of protons found in the nucleus. Okay, Z is the proton found in the nucleus. So when you look at the isotope itself, what does it mean by isotope? So that is the most important thing that you need to be thinking of. So isotopes, the definitions that we have is this. You can use this. This is one of the most common definitions for isotopes. So isotopes are two or more atoms of the same element. So you need to have two or more atoms, and you need to mention the same elements, and they have the same number of protons in the nucleus, but different number of neutrons. So that is the definition of isotopes. Okay. So when we look at one examples, let's say we take hydrogen. Okay, so this hydrogen, the symbol will be H, of course, okay? And then A equals to 1, the mass number is equals to 1, and the proton number equals to 1 as well. So what is the isotopic notation? So how are you going to write that? So this is how you're going to write it. It's very simple. So what you have over here, the symbol X is H. You're going to write it there, very specifically for hydrogen. And you have the value of A, which is 1. You're going to put 1 over here, just like what you have A right there. And then Z, 1, right here. Okay, so let's have a look at more examples for hydrogen. So this is the same hydrogen that we have just now. So Z is the proton number 1, and you have 1 on top. So A, the nucleon number is 1, or the mass number is 1. Therefore, neutrons in this hydrogen isotopes, also known as protium, is 0. It does not have a neutron. Okay? So let's have a look at the other two. Look at the other two. You have deuterium. Okay, now it's slightly different now. You have 2, so the nucleon number will be 2. So 2 minus 1, you'll get 1 neutron. So inside deuterium, it has 1 proton. Okay, you have 1 proton and 1 neutron. Okay, 2 over here refers to the nucleon number. And the next one is this, when you have tritium. Tritium, instead of 2, you have 3. So 3, the nucleon number is 3. Proton number is 1. And the neutron is just simply taking 3 minus 1, you'll get 2. Okay, so the number of proton is 1. The number of neutrons is 2. So how many electrons in here? Remember, If you do not have a charge, like what you have in here, you do not have a charge, proton number, okay, is the same as the electron number for neutral species. Okay, so there's, I'm going to write that properly for you. Species. Okay, so the word species over here refers to your tritium, deuterium, and protium. Now, proton number will be the same as the electron number. If you have this statement, since they are neutral species, the electrons for all of them will be 1 because they have 1 proton number. Now, same goes to carbon. You have 12, okay, 12 nucleon number, 6 proton number, 12 minus 6, you have 6 neutrons. And same goes to carbon 13 and carbon 14. Now we're going to try and do some questions here. Okay, so you have 4 species. Okay, given to you, you have 4 species, and you need to give the number of protons, neutrons, and electrons. And you need to state what is the charge. Obviously, for Hg or mercury and copper, the charge is 0, yes? So over here, the charge is 0 because they do not have charge. If you look there, you don't have charge. Like these two, they have charges. Okay, so when they have charges, that one will be 2 negative. This one is 3 plus charge. Okay, for the charge, that is okay. So what about the proton number? Okay, what is the proton number over here? For mercury, is it 200 or is it 80? Of course, it is going to be 80. And then the neutron is 120. How do you get that? How do you get the number of neutron 1 to 0? You're simply going to take 200 minus 80. Okay, remember what we have talked about before this. So this number is when you have 200 minus 80 to get the number of neutron. Remember, this is not nucleon number, this is neutron number. So what about the number of electron? We have 0 charge, you have 80 protons, uncharged species, thus you have the same number of electrons. For copper, you have 29 right over here, and then 63 minus 29. Okay, 63 minus 29, you'll get the number of neutron, 34. And the number of electrons is the same as the number of protons. Okay, electrons and protons will have the same number because you are uncharged species. And for oxygen, you have 8. 17 minus 8, you have 9. For the electrons, since you have charge, 2 minus means you have 2 additional electrons. You have 10 now, okay, 10 electrons. They cannot be the same, okay? You have 8 over here. You cannot have 8 over here because you have charge 2 minus. 2 minus means you have 2 additional electrons. So 8 plus 2, you have 10. I hope that is clear, okay? Now, for cobalt, you have 27, proton number 27, and you take 59 minus 27, you'll get 32. This time, instead of adding electrons, you are going to be taking away electrons. If cobalt is uncharged, the number of electrons will be the same as the number of protons, isn't it? You can have 27. But this time, the species has lost 3 electrons. So 27 minus 3, you have 24. That's how you're going to look at the piece of information from the isotopic symbol.